So we are going to have solutions of Dirac equation for free body. So we are going to use our in the last class we used the covariance, our principle covariance, and some of the things of covariance which we did there we are going to use here. But the thing which last we just हमने सिर्फ positive solutions, we did not take solutions. हमारे पास आता था +1 -1 +1 -1 चार solutions. So we took the solutions Dirac system के only the positive solutions. Why did not we took negative solutions? क्योंकि हमने कहा they will correspond to negative probabilities which are not allowed. But later we said that we can take those solutions also and they will correspond to the antiparticles in some sense. Okay? अब ये है कि we are going to see the solutions in the widest possible sense, which will not only include the positive energy solutions as well as the negative energy solutions in that sense, using the idea of how we have a signorial representation of Dirac. So for a free particle, and which will also satisfy the requirements of Lorentz covariance or Lorentz transformation. Okay. Lorentz covariance में कैसे दिखाया? We put two reference frame and we try to see the observations how they register in two reference frames. If they are somewhat related, so in the same we have to show covariance of two events in two reference frames which are related. अब हमारे पास अगर हमारे पास free particle है which has four solutions which correspond to free particle and which can be written in the combined form as such or can be written as epsilon r mc square by h into t, where r can go to 1, 2, 3 and 4. Okay, and maybe this epsilon r can go for either it will go for +1 or it will go for minus. So r can go from 1 to 2 and r goes from 3 to 4. Okay, in that sense. And which are the signals corresponding to them are, for example, omega 1 0 can be 1 0 0 0, omega 2 will be 0 1 0 0, omega 3 will be 0 0 1 0, and omega 4 will be 0 0 0. Fine? अब जो हमारे पास नेगेटिव एनर्जी सॉल्यूशन हैं, they will for r is we have not taken, they will for r is going to be 4 which remain to be interpreted, which remain to be other two we have interpreted in that sense. And जो हमारे पास आइगन फंक्शंस हैं sigma z which is basically sigma 1 to sigma 1 जो भी है 2 1 2 जो भी हमारे पास so it will be for which have eigenvalues either +1 eigenvalues or -1. So जो Lorentz transformation है हमारे पास Lorentz transformation which has a sign of x is equal to so हमने कहा they obey linearity properties such that s of a of psi x is equal to s of a psi a minus. So if they obey this linearity property, where s is some transformation matrix, so psi can be related with this side, so psi can be related with this side. So this is a linearity property. So you have to see this linearity property for negative eigenvalues also. Okay, this is the thing. साइड दैट जो हमारे पास जो है किसी स्पेस टाइम कोऑर्डिनेट डायरेक्शन जो हमारे पास so for it will be in that sense so it will be so it will be like this. So you have to see the space and coordinate invariance. So it's basically exponential function. Exponential function क्या है? ये cos का function भी है, sin. So the sequential part sigma, basically it can be written as both the cos part and together they will form this transformation. अब इसका जो MC square है, this function psi is it transforms like this. Now this psi is the exponential part. You can write it like, if you want to write it in terms of this is mass into c square. You want to write it in terms of momentum. You want to write it in terms of momentum. So you can write it as exponential of momentum. So MC के बजाय आप P है ना? MC into C है. C is so MC के बजाय आप P mu and फिर वहाँ पे आएगा P के साथ बढ़ जाएगा. So you can write it the other one you can write it as X mu. Yes, X mu. So mu can go from 0, 1 to 3. You can go from 0, 1 to 3. So this is, so you can represent this like this in terms of cushion and momentum. Or you can write it as x with 9 like this. Where x mu can be written as a mu x. How can this is the transformation matrix? So it's the right transformation power x. So you can mu contracts. So how x mu can be related with this via some transformation matrix in that sense. And the same way, p mu can be written as a mu or it can be written as a mu 0. So our notation how it can p can be written as e by c. E is equal to mc square. You can write it like this, or you can write it as e square plus m square c square greater than 0. अब इसके हमने we have taken the positive energy solutions. So our aim in this class is also to include the negative energy solutions for the solution of this Dirac free particle in that sense. So we have also to take into consideration here this and this one. Once we introduce it here in that sense, and say that p mu is equal to mc square is greater than. So now what we are going to see, so we are going to transform the signals as S is equal minus omega sigma 01. So this is a signal transform. Basically exponential function. These omega sigma zeros are different matrices. Sigma 1, sigma 01, 02, 03, 1, 0, 1, 2, 1, 3, etc. And those sigmas later we write it in terms of gammas. अब ये है कि हमारे पास इफ यू रिमेंबर इफ यू जस्ट टेक आवर थोड़ा सा स्पेशल थ्योरी ऑफ रिलेटिविटी पे जाएंगे तो वहाँ क्या है, इट इज एन अपर बाउंड ऑफ वेलोसिटी. When you try to understand, you might have studied elements who have speed time diagram of ऐसे लगते. So what's it? It's a light cone. It's completely forbidden region. Because light cone है, but basically this and this क्या है? B by C. That's it. So it's basically how can C, if it's C, it's B by C, so it's sort of that tan theta, the events lie within this bound, within this part. So the ratio of velocity of light to the velocity of that particle, that's V by C, the ratio. It should be less than 1, it cannot be greater than 1. So if you have to incorporate special theory of relativity out here, so if you remember in the last class, at the end we had the solution of special theory of relativity equations to form. It was like this. So I write it here. So हमने in terms of the coordinates x0, x1, x2 and x3. So इसका form ऐसे आ रहा है in terms of cost functions, sin 0 0, sin of omega cos 0 0, 0 0 1 0 0 0 0 1. So it's x0, x1, x2 prime, x3. ठीक है? So x0 is point is related to x via this. So it was the equation we got from special theory of relativity. So we have जो हमारे पास velocities हैं particle की velocity of light and velocity of particle. इनको में sines and cosines हमने किया. Side that हमारे पास जो function यहाँ पर है in that sense which we are going to see, which is also called Lorentz angle, which is called Lorentz angle omega is given by like this. Omega is given V by C, or tan of omega is equal to हमारे पास जो Lorentz angle है it's V by C. Now हमारा काम अब क्या है? Now the point is जो हमारे पास ये ट्रांसफॉर्मेशन है, it should not only include the solutions of positive particles but also negative particles, and the transformation should be Suhail. Should be Suhail in the sense that it should satisfy this transformation. This is the transformation matrix, and which is obeying these linearity properties. Okay. So now again, what we are going to do? We are going to do the transformation. Side that जो हमारे पास ओमेगा और P is basically so this omega or this omega by 2. अब इसमें sigma 0 1. Now, if you want to write it in terms of cos and sin, so it will be cos of omega by 2. So again, जिस तरह if you remember, यहाँ पर अगर हम इसको बाहर निकालेंगे, है ना, cos को बाहर निकालेंगे, it will be 1 minus tan of x omega. जाएगा tan x omega 1 0 0. अगर बाहर निकालेंगे ब्रैकेट से बाहर, ठीक है. In the same way we can do the same thing here, But here the solutions are only for positive particles. So if you take all the four matrices, which include sigma 01, sigma 02, 3, 4, positive as well as negative particles, so it will and taking cost of H omega bar. तो ये मान 0, 0 फिर तीसरा आएगा हमारे पास tan H omega नहीं यहाँ पर cos omega कोई नहीं है tan omega पर तो भाई cos omega cos कर देगा तो यहाँ पर फिर माइनस 0, 1 Actually, we had done जो हमारे पास just go through. We have applied 3.4. So this is 3.4 to our equation, Kuhn's-Weyl equation, where omega 1 is equal to 1, 0, 0, 0, omega 2 आएगा 0, 1, 0, 0, omega 3 omega 1, 2, omega 4, 0, 0. So this code is notebook velocity. So you got its sign and you got this. Okay. अब ये आपका exercise करना, taking this equation and these values of omega, which not only includes positive values, which also includes these two solutions. So we get this transformation matrix. So अगर हमारे पास ये है and again since we here we use trigonometric identities, which you can find in any book of trigonometry. So tan of H omega by 2 can also be written as so you can write it. It's a trigonometric value. So again, since tan of H omega, you can write it as d by c. d by लिख सकते हैं. Now you multiply both sides by mc square. Is equal to mc square. यहाँ mc square आएगा ये कैंसिल हो जाएगा mc आएगा ऊपर. That will be basically p of c divided by 2. ठीक है. Just do it here. हमारा मकसद सिर्फ ये है to write this function, velocity of the particle vis-a-vis velocity of light. V by c we write it in terms of tan of this function. Okay. From trigonometry, so we can also write tan of this function as this, and further we can write cos of this as this. Now we are coming to, if you remember, last time हमने कहा था just like we did this thing. हमने in terms of I mu. So when we look infinitesimal rotations, infinitesimal rotations क्या हो गया? दो रेफरेंस फ्रेम ले लिए, एक रेफरेंस फ्रेम लिया, दूसरा रेफरेंस फ्रेम. So one is infinitesimally rotating. ठीक है? So we have to map coordinates of this space to the other space, and we have to see whether it's Lorentz transforming or. तो हमने क्या किया था? हमने मैट्रिक्स को ऐसे भी डिफाइन किया था. Such that I01, I10, so it's equal to minus 1. So the way we define proper and improper. So now we are going to do the same thing here. So infinitesimal rotation transformation for using this matrix. So now the book says that the thing is that you have to work it out. So he has replaced this I mu. So you can have I mu ऊपर भी नीचे भी, ठीक है? So I mu, so it may be a row or it may be a column. So I mu can be written as so these are the direction cosines basically. Direction cosines means what? जिस तरह हम कहते हैं ना tan of h beta is basically by it's a ratio of velocity of particle to the velocity of इस तरह cosine angle क्या होता है? Direction cosines क्या होता है? इसमें एक angle cos है, सिर्फ हमें cos को नहीं आना चाहिए, ठीक है? We can see it accordingly. And if you remember, x0 from this matrix. X0 is cos x0 x prime. So one x is equal to x. Now the transformation matrix can be, so if it is sigma mu, I mu, and so the transformation matrix will be twice क्या आएगा ट्रांसफॉर्मेशन मैट्रिक्स? एक तो आ गया सिग्मा 01, सिग्मा 02, सिग्मा 03, इसलिए सिग्मा 10, सिग्मा 1, सिग्मा 1 ऐसे. For a particular case it will be एक के लिए आएगा, another is sigma 01, and the third is cos gamma. You can write it as in terms of, if you want to write it in terms of direction cosines, you can write it as alpha dot b by alpha dot b by alpha, and then cos alpha, cos beta, cos gamma. So this is direction cosine. So we can write it like this. So now you are coming back to where we started. So we are coming back. So now जो हमारे पास S matrix है ये S. This is the कौन सा matrix है? S हमारे पास transformation matrix. By which we can relate coordinates in one plane in the other plane. So this is the transformation matrix. So now this S can now, in presence of these direction cosines, we can write it as S is exponential of now what we are going to do, since हमारे पास cos of omega का हमने लिखा ऐसे, cos of omega is basically E plus mc square by 2mc square. Now we are going to substitute here and use transformation matrix. जो cos omega अगर बाहर निकालेंगे यहाँ पर, so it will be, so it's a bit of work of figure. So now you are getting this cos of omega and substituting it here, and how this entire matrix will come under 4 cross, which not only includes the positive energy solutions but also negative energy, all the 4. Omega 1, omega 2, omega 3, omega 4. इसका फॉर्म अगर इसको बाहर निकालें, जिस तरह cos omega है, cos omega के बदले हम tan omega के बदले हम लिखेंगे tan h omega के बदले लिखेंगे dc by e plus mc. So if you write these two and matrix that will be so we can write it like this. ये cost के बदले cost होता है ना बाहर always take cost outside. यहाँ निकालते हैं cost बाहर निकालते हैं मान होता है tan of x ओमेगा है 0 ये tan of x ओमेगा आएगा ये मान आएगा 0 अब ये for है हम for positive energy solution. जब हम negative energy solution लेंगे so the equations will take this form. अब ये देखो ये cost के बदले हमने e लिखा. This is the solution. And tan के बदले हमने we have written this. E p square by e square plus h square. Tan के बदले ये लिखा, cost के बदले and did the substitutions there. So this matrix we can do at your place. कौन-कौन से इसमें यहाँ पर see value will come right where px is p plus. So the general, if you want to say the general form of free particle solution, which includes both positive as well as negative solutions, we can written as epsilon r. If you remember, start में यहाँ sigma हम उसको write किया था in terms of p mu x mu iota by x. Where r is the column vector corresponding to and which is written by in terms of gamma matrix. If you remember one of your classes, so they are going to satisfy following useful relations. कौन-कौन सी? एक रिलेशन हमारे पास so which is one, it's derivation है यहाँ पर क्या है Forman solutions, and the other is omega or derivation for so other set of particles. ठीक है, इसका एक का ये solution आएगा, दूसरे का so we have only flipped. देखो यहाँ पर ये flip हो गया यहाँ से, omega RT is split by omega bar RT. So if you want to write, put more compact notation, if you want to write it in more compact notation, so you can write it as R is equal to 1, और क्या है कहाँ से 1 to 2 नहीं आएगा 1 to 4 आएगा है ना 4 आएगा 4 में आएगा sigma 0, sigma 1, sigma 2 and sigma 3, which is basically incorporated in terms of gammas. ठीक है आप ये है so we can write it as, so in compact notation we can write it as लिख सकते हैं इसको ऐसे, तो ये अपना है ना और ये ओमेगा ये है, so either it can be 0 or it can be 1. so अब अपनी जगह आप देख लें कैसे आ सकता है, so you multiply this term यहाँ इस टर्म के साथ एक अलग इसके साथ एक 4 terms आ गए, ठीक है. So the thing is just like you write Kronecker delta. So you can write these two solutions in compact notation like this. One second. अब ये है कि उनका sometimes, so if you remember sigmas were in terms of gammas, है ना, gamma square is equal to plus gamma 0 is equal to gamma mu dagger is equal to gamma mu. Basically जिस तरह आप नॉर्मलाइजेशन निकालते हैं क्वांटम मैकेनिक्स में psi star d3x ऐसे करते हैं, ये किसके बराबर है ना, so you have sort of normalization. So in the same way it's also sort of normalization of these probability densities of the solutions of Dirac equation for free particles, which includes both positive solutions as well as negative solutions. Okay. In compact form of positive and negative solutions ऐसा एक equation, otherwise एक ये दूसरे के लिए this will correspond to this and this will correspond to this and if you अपनी जगह आप एक एक्सरसाइज है which I only just did and you see more. So this epsilon RP epsilon RP is basically E1 MC square delta R. So if you multiply this by this, it will exactly get cancelled by this factor of E by MC square. So we get this normalization constant exactly back. So we'll just discuss this tomorrow. Just come along. So multiply this and this. What do you mean by getting this back? And what physical significance it has in that sense. Okay?